Welcome to Future Doctor NEET Academy for the problem solving session in NEET Physics. Topic today chosen is from chapter 9, Mechanical Properties of Fluids. Let's move to question number 1. Next question. A barometer is constructed using a liquid density 760 kilogram per meter cube. What would be the height of the liquid column when a mercury barometer reads 76 centimeter? Density of mercury is given 13,600 kilogram per meter cube. That is, pressure at both the sides will be equal. That is a formula. P1 equal to P2. P1 is H1 rho 1 G equal to H2 rho 2 into G. And we want to find what will be the height of the liquid column. So H1 you want to find. Therefore, H1 equal to G getting cancelled here. G getting cancelled. Then H1 equal to H2 rho 2 by rho 1. H2 rho 2 is 76 centimeter. 76 centimeter convert into meter. 76 into 10 power minus 2. 76 into 10 power minus 2 into rho 2. Rho 2 is 13,600. 13,600 divided by 760. That is a rho 1 is 760. Then simplify this. 76 10 times equal to this 0 getting cancelled. Then we will get 13.6. 13.6 meter. That is option B. Option B is the answer. Let's move to question number 2. A tube with both ends open to the atmosphere is partially filled with water. Oil which is immiscible with water is poured into one side until it stands at a distance of 10 millimeter above the water level on the other side. Meanwhile, the water rises by 65 millimeter from its original level. The density of oil is dash. This is also same formula as previous. That is H1 rho 1 G equal to H2 rho 2. Here you want to find rho 1. Rho 1 equal to G getting cancelled. H2 rho 2 by H1. Okay. And H2 is, that is a rho 1 equal to, H2 is 65 millimeter plus 65. 65 plus 65 into density. Density of water is 1000 into 1000 divided by 65 plus 65 plus this 10. 65 plus 65 plus 10. Then rho 1 equal to 65 plus 65 130. 130 into 100. 130 into 100 divided by 130 plus 10 140. Then this 0 getting cancelled. Density 1000, no 1000. So 130 into 1000. So here this 0 getting cancelled. Then 13 by 14. 130 by 14 will be 9.28. 9.28 into 100. That is equal to 928. 928 kilogram per meter cube. 928 kilogram per meter cube. So option D. Option D is the correct answer. Third question. The approximate depth of an ocean is 2,700 meter. The compressibility of water is 45.4 into 10 power minus 11 per Pascal. That is, compressibility is the reciprocal of bulk modulus. And density of water is 10 kilogram per meter cube. What fractional compression of water will be obtained at the bottom of the ocean? Fractional compression equal to compressibility into pressure. Okay. Fractional compression equal to compressibility into pressure. Okay. Then pressure formula. Pressure equal to H rho G, or instead of H, dense, that is a depth is given. Is it so? Depth 2700 meter. So pressure P equal to H rho G can be written as D rho G. H is height, D is a depth. Both will be in meter. Okay. And D is 2700. 2700 into rho. What's the density? Density is water only given, no? So 1000, 10 power 3 into G. G, acceleration due to gravity, keep as 10. Then this is equal to 27 into 10 power 2, 10 power 4, 10 power 5. 27 into 10 power 5. unit Newton per meter square. 27 into 10 power 5, no, 3, 4, 10 power 3, 4, 5, 6, 10 power 6. 10 power 6 Newton per meter square. Okay. Substitute this in fractional compression. Fractional compression equal to compressibility given as 45.4 into 10 power minus 11. 45.4 into 10 power minus 11 into 27 into 10 power 6. 27 into 10 power 6 equal to, if you simplify, you will get 1.2 into 10 power minus 2. Okay, this is the fractional compression, option C. Let's move to question number 4. A small sphere of radius r falls from rest in a viscous liquid. As a result, heat is produced due to viscous force. The rate of production of heat when the sphere attains its terminal velocity is proportional to dash. That is the rate of production, dq by dt. dq by dt, that is equal to that is power. Power is force into velocity. Force into velocity, that may be a terminal velocity. For viscous force, it's a terminal velocity. So dq by dt equal to f into v. And f equal to 6 pi eta rv, that is from Stokes' law. F equal to 6 pi eta rv. V is the terminal velocity and r is the radius of a sphere. Substitute this here. Then dq by dt equal to f is 6 pi eta r into v square. This v only terminal velocity. Okay. And terminal velocity v equal to 2 by 9 rho minus sigma into r square g by eta. So from this terminal velocity v is proportional to r square. Okay. And rate of production depends upon, that is proportional to only, there's a question. Then substitute this v is proportional to r square here. Then dq by dt equal to 6 pi and v is r square. So r into r square is r square whole square. 6 pi and all if you remove, 6 pi eta and all if you remove means, then dq by dt equal to not equal to, is proportional to, because we are remove constant things. So this proportional to r square power 2 is r power 4, r power 4 into 2, r power 5. That is option A. Option A is the correct answer. Let's move to question number 5. A wind with speed 40 meters per second blows parallel to the roof of a house. The area of the roof is 250 meters square. Assuming that the pressure inside the house is atmospheric pressure, the force exerted by the wind on the roof and the direction of the force will be dash. This is Bernoulli's theorem formula. That is pressure energy and velocity energy. Velocity, pressure rate and velocity rate is equal to constant. Okay, that only we are applying. Then P1 plus 1 by 2 rho into V1 square minus V2 square. V1 square minus, next step only it will come, half into rho V1 square equal to P2 into P2 plus half into rho V2 square. P1 minus P2 equal to, from this P1 minus P2 equal to 1 by 2 into rho into V2 square minus V1 square. V2 square minus V1 square. Substitute this. That is equal to 1 by 2 into rho. What is the rho? Is the density is given 1.2 kilogram per meter cube. 1.2 into V2. V2 is 40 minus 0. That is blow parallel to a roof of a house. Roof of a house 40 meter per second. So 40 square minus 0. 40 square minus 0. Then this you can simplify this as 1 by 2 into 1.2 as 0.6. 0.6 into 40 square. 40 square is 4416. So 1600. Okay, 1600. And simplify this. 1 0. After that, point outside. 0 point 1600. Then this gives 6636, 616, 789, 96. 96 and 0. 960. 960 Newton per meter square. And you want to find a force. Force F equal to pressure into area. Pressure is 960. 960 into area. Area is 250. Then F equal to 960 into 250, you will get 2.4 into 10 power 5 Newton, and it will be acting upwards only. That is, pressure is acting only on the top and no pressure at the bottom. So it is upwards. Upwards, that is option C. Let's move to question number 6. A liquid does not wet the solid surface if angle of contact is dash. That is, if angle of contact theta is obtuse. If theta is obtuse. Obtuse means theta value is greater than 90 degree. Then only it will not wet the glass. Best example is mercury. Option C. Let's move to question number 7. Last question. A rectangular film of liquid is extended from 4 cm into 2 cm to 5 cm into 4 cm. If the work done is 3 into 10 power minus 4 joules, the value of surface tension of the liquid is dash. Surface tension equal to work done per area. That is the formula. Delta E only we want to find. Delta A equal to, formula is, I'll write this side. Delta A equal to, that is this area 5 into 4. 5 into 4 minus 4 into 2. 4 into 2. And it has 2 surfaces, no? So into 2. And 5 4 20. 20 minus 4 2 8 into 2. So how much? 20 minus 8 12. 12 into 2 24. 12 into 2 24, yes. 24 centimeter square. Because we haven't converted into meter. It's centimeter square. Then substitute this here. Surface tension T equal to W by delta A. T equal to W by delta A. W is given 3 into 10 power minus 4. 3 into 10 power minus 4 divided by 24 centimeter square. 24 centimeter convert into meter, that is 10 power minus 2 whole power 2. So 10 power minus 4. Directly I am writing 10 power minus 24 minus 4. 10 power minus 4. Simplifies is 3, 8, 24. And 10 power minus 4, 10 power minus 4 getting cancelled. 1 by 8. 1 by 8 equal to 1 by 8 equal to 0.125. 0.125 unit Newton per meter square. Newton by meter square. That is option. Option B is the correct answer. Next session, we will see through another chapter. Thank you.